All right, let's dive into something that can look a little tricky at first, multi-step inequalities. But here's a little secret. If you already know how to solve a basic equation, you are 99% of the way there. Seriously, let's get right into it. Just take a look at this. On the left, we've got a standard two-step equation, no problem. And on the right, an inequality. See how similar they are? Same numbers, same variable, and guess what? The steps to solve them are almost exactly the same. We're just going to add one tiny but super important rule at the very end. I absolutely love this peeling the onion analogy. It's just perfect. When you're trying to get x all by itself, you're really just working from the outside in, undoing every operation one step at a time. You use subtraction to undo addition, division to undo multiplication. You get the idea. The only thing we have to do is keep an eye out for one very specific situation. So, to make sure we always know what to do next, we're going to use a simple four-step checklist. This is our game plan. You follow these steps in this order, and you're going to nail it every single time. And here it is. Step 1, if you see any parentheses, you distribute to get rid of them. Easy. Step 2, you clean things up by combining any like terms on each side of the inequality. Step 3, you start getting the variable alone by adding or subtracting the constant term. And then there's step 4, multiply or divide to finally get x by itself. Now, lean in close for step 4 because that is where our one game-changing new rule is hiding. More on that in just a second. Okay, enough theory. You don't learn math by talking about it, you learn it by doing it, right? So let's put our checklist to the test with a few examples. We'll start with an easy one to get warmed up. Here we go. 3x minus 7 is less than 8. Hey, wait a minute. That's the same problem from the first slide. So let's use our checklist. Any parentheses? Nope. Any like terms to combine on one side? Nope. So we can jump straight to step 3. First, we need to undo that minus 7. So we do the opposite. Add 7 to both sides. That leaves us with 3x is less than 15. Now for the last step. We divide both sides by 3 to get x alone. 15 divided by 3 is 5. So our answer is x is less than 5. So did you notice what happened there? Or what didn't happen? We divided by a positive 3, and the less than symbol just stayed a less than symbol. Nothing changed. Which, of course, leads to the big question. What happens when that final step involves dividing by a negative number? This, right here, is the one and only new rule you have to learn for inequalities. It's the key to the whole thing. Let's see it in action. Our problem is negative 2x plus 4 is greater than or equal to 16. Okay, checklist time. No distribution, no like terms to combine, so we start by getting that variable term by itself. First step. We subtract 4 from both sides. No problem. That gives us negative 2x is greater than or equal to 12. Now, for that final step, we need to divide by negative 2. 12 divided by negative 2 is negative 6. But what about the symbol? What do we put in that question mark? And here it is, the flip rule. When you multiply or divide both sides of an inequality by a negative number, you must flip the direction of the inequality symbol. So greater than becomes less than or equal to becomes greater than or equal to. It just flips right around. So back to our problem. Since we divided by a negative 2, that greater than or equal to symbol does a complete 180 and becomes less than or equal to. And that's it. That's the whole game. The final answer is x is less than or equal to negative 6. Okay, let's do one more to put it all together. This one's got the whole shebang. We have negative 3 times the quantity x plus 2 is less than 9. Time for our checklist. And hey, we finally get to use step 1. First, we distribute that negative 3 across the parentheses. That gets us negative 3x minus 6 is less than 9. Next, we add 6 to both sides, which leaves us with negative 3x is less than 15. And now, for the grand finale. We divide by negative 3. And because we're dividing by a negative, what do? We flip that symbol. Our final answer, x is greater than negative 5. Now that you know the moves, let's talk about defense. There are 2 really common traps people fall into with these problems. But once you know what they are, they're super easy to avoid. The first trap is the most obvious one. You just forget to flip.
You get in the zone, you're doing the math, and you just go on autopilot and leave the symbol as is. Always, always double-check that final step. The second trap is a simple sign error when you're distributing. It's a tiny mistake that can mess up the whole problem.
And here is exactly what I mean. When you distribute a -2 to a -5, your brain can easily just write down -10. But wait, a negative times a negative is a positive, so it should be +10. You have got to be careful with those signs. They make all the difference. And now we get to the question that I know is on your mind. Yeah, but when am I ever going to use this in real life? Turns out inequalities are everywhere, helping us figure out all the limits and boundaries in the world. Let's take a look. So picture this. You're planning a party and you've got a budget of $100. That's your limit. The room costs a flat $40 and then it's $5 per person for pizza. The question is, how many people can you actually invite? Well, believe it or not, this exact situation can be written as an inequality. The $40 room fee plus $5 times X, the number of people, has to be less than or equal to your $100 budget. And hey, that looks just like the kind of problem we've been solving. So when we solve it, we subtract the 40 from the budget, then divide by the $5 per person. The math tells us that X has to be less than or equal to 24. So there's our answer. You can invite a maximum of 24 people to the party. Any more than that, and you go over budget. And that is the real power of this. This isn't just about X on a piece of paper. This is a tool you can use to understand the real world. Budgets, speed limits, how many people can safely fit in an elevator. Anytime there's a limit, an inequality can help you figure it out. You just use math to figure out a real-world party guest list. So now that you have this skill, I'll leave you with a question. What other limits in your life, in your budget, your time, even your goals, can you now describe and calculate with an inequality? Think about it. Thanks for tuning in.